And now for this session, I want us to look deeper into some of the data structures too, and also some of the things that you have covered. And in this case, we'll look at some of the major data structures that we have. And for data structures, these are the things that normally store our data. Last time we looked at a linear search, and for that linear search, we used a data structure that is called an array. And for accessing an array and using a linear search, you have to go through all the elements of the array from beginning to end. And that is why that is not really recommended, because we gave an example and say that if, let's say, Google was doing that to trillions of petabytes of data, it would take an eternity to find some data that is in the trillionth category. So that's why we have some efficient data structures. So these data structures is something like dictionaries, hash maps, more of the same things. When you store your data in some efficient data structures, it becomes more efficient to even retrieve your data. And in this case, today we are going to look at some of the two major data structures that are used, quite common, and these are what we call the queues and the stacks. This is actually quite even examinable, the queues and the stacks. So for this, we have their differences and their major use cases. And so to demonstrate them, I think I can just create a new console application. You just do a console application and then I can go. Then I want it to be in C. The project title to be stacks and queues. Stacks and queues. And I need to specify the project. The project. Where do I put it? I think I can put it just on the desktop. Yeah, there's nothing on the desktop. And then I can choose the compiler and it will create our project right over here. So we just have this hello world. So to test everything is running, I will just build and run. And if hello world displays, I can see that it shows me that my program is executing perfectly. So that is good. So today I can display another message. Let's say today we are learning about queues and stacks, and I can run it. And today we are learning about queues and stacks. Good, everything is good. And to do a brief introduction as to how some of these data types are used, and I told you, if you have any problems in hearing me, just feel free to raise up your hand. I think you can be able to raise up your hand or just send a message on the chat. uh, I will get a clear notification and I'll be able to hear. So that is, if maybe in case of anything, just feel free to interrupt me anytime. You know the drill. And yeah, so for this, I think I can start by commenting. Let me see whether we can have some comments. So I'm just writing some comments to explain more of these data structures and algorithms. And in this case, I want to I want us to know more about the stacks. So for the stacks, think of the stacks as is a data structures that is a data structure that produces something that was input last. So it will majorly be attributed with something we call LIFO for last in, first out. And then for Q, Qs, this is what we call the first in, first out. First in, first out. And what we mean by this is that the last data that you put into a stack. So the last element that you put in a stack will be the first one that is retrieved. And then for the queues, the first element that you put in a queue will be the first that will be retrieved. Okay. And what are some of the uses? Where can now these be used? So for something like a queues, so queues can literally be used in queuing queuing systems. How do we write queuing? Queuing system. Okay, whatever. Cool. Oh, there's not the second E. Yeah, so they can literally be used in queuing systems. So the queuing systems is like uh maybe maybe what we have in banks. Okay, to give an example, when you visit a bank, you normally pick a ticket, or so many services nowadays that are really crowded. You normally pick up a ticket, and then when you pick up that ticket, when your time comes, you are normally called. So for that system to be fair enough, it has to use a queue, because when you come in first, you should be served first. So majorly, you'll tend to see that for such systems, we use queues where we need to really preserve order. So queuing systems. Now, these can include even in hospitals. Some of hospitals have the queuing systems, and also just even when you're parading yourself on a line to get food, that is a queuing system. So if you rush to the, let's say you're in a wedding and you want to get served food fast, so you just rush fast to the line, and because you rushed fast to the line, you are served first, and that is a literal explanation of a queue. So anytime you're in a line, just know that you're implementing a queue IRL, okay, in real life. So anytime you're just waiting in line for food, for service, just know that you're implementing a queue on in real life. The other one is a stack. So for a stack, you might tend to wonder majorly what kind of systems use stacks. So one of the major systems that use stacks is one of the most common things that you use. And what is that? That is the undo button. So for something like the undo button, if I was to undo Control Z, you can see it is undo and redo. Redo, I think, is Control Y. So these undoing undo and redo. Let's actually and redo. These undo and redo, what majorly these programs have done is that they take control of the most programs take note of things that you have been doing recently. If you want to go back to maybe where you were, you can retrieve that data by undoing. And if you want to return back to where you were, you can redo. Okay, this is majorly what we can, that is what is happening here. I can actually control Z and just delete, let's say, like delete the my most recent data. You can see it is not touching the data that was here, because as I was typing, the data that was here was added quite a long time ago. But when I redo, you can see my most recent data has been redone. Okay, that is one of the use cases of stacks. Another major use case of stacks is normally used in web browsing. This is on the this is to display your history, and also on the back button of the web browser, and we'll actually see this in real time. So once you go to your browser history, I don't know whether I should show you my browser history. But I'm so clean, so I should not have anything history. You can see my browser history. So you can see that it is just stored. It's just stored on. I can actually even zoom. So it is storing in terms of uh, what I visited last, and you can see we are in a Google Meet, and it has listed it first. So remember the philosophy we had for stacks: last in, first out. So the last that we were in is the first here. And then before that, at 8:32, you can see even the timestamps. At 8:32, I was at the Google Meet. 8:32 again, I was at the Google Calendar, maybe setting this meeting up. I was also 8:30. I was maybe doing some code blocks, downloading code blocks. So this is just basically the, what do you call it? Basically the stack, one of the data structure that is majorly used here. I would presume is a stack. And also, when I press this back button at the top, when you see, if I want to go back, so let's say I wanted to browse Google, and then Google Meet. I don't know why. And then after doing Google Meet, I go to which other site can I go to? Canva. I go to Canva. I'm just trying to go to different websites. I go to Claude AI. After going to Claude, I go to what else? Uh, Give me another site I can go to: ChatGPT, whatever, LinkedIn, Sora. Can go to Sora. So what I want to show you is that as I have been visiting these websites, if I click on the back button, I should go back to the most recent website that I had actually visited. So if I go back, click on go back, I should go to Claude, and they should be in that order. After Claude, I think I visited Canva. Before Claude, I think it was Canva exactly. Before Canva, I think it was, I searched for Canva, and before Canva, it was Google Meet. So what I want to show you is that if I go to the most recent, after this, I can go to Sora. If I go to the most recent and then I right click on the back button, okay, you see when I right click on the back button right over here, it shows me, it just shows me like my recent history. You can see it's Claude, Canva, and then Google Meet. So you can see that is some of the real life applications of these things, something like a stack. So I think now you have a good grasp of how these things can be used in real life systems. And so in this case, what you're going to do is you're going to implement one of these, or if time allows, we can implement both of them, implement both of them when it comes to when it comes to C programming, so that you can see how they are done in C. But trust me, you won't be doing like this in real life. You won't be implementing stacks like this in real life. But maybe the time that you might find such an implementation where you're told to maybe implement them from scratch, like our case, it is maybe when you're doing maybe interviews. Okay, maybe you land a Google interview. Yeah, you can be told to write some crazy code to just do some sort of things like these. And yeah, and so what I can do is I can just get to implementing the system, and I think I will leave this as is, because maybe you might want to check up on this discussion that we had. And so, what else? Yeah, as I was saying, you won't be doing this. So, for this, you need to understand, because in this maybe course, you're doing C, and this is required in your coursework and also maybe in your exams. This is something that can also be examined. And so, for the normal languages that you will find yourself using in the real world, let's say these higher level programming languages such as Python, Java, C Sharp, JavaScript, they have all these things inbuilt. If it's a stack, there's a inbuilt stack, there's an inbuilt queues, all those are inbuilt. So you don't have to do all the work that you will be seeing us doing here. But for practice purposes, you can know how they are normally done from scratch. So what this program does is that it first of all, it just displays the message that is right over here. After displaying that message, it basically does nothing else. And what you now want to do is to make sure that our program is robust and it implements. Let's start with a stack. And so for this, we'll use another preprocessor directive for us to maybe delete the console. So we can say include something we call conio.h. So this is also used in the console. So you'll see some of the things that, but it's not necessary. Okay, it's not necessary, because this will majorly be used to give us function like the 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 clear screen. Okay, let's see whether it's actually the directive that gives us that kind of functionality. um so You see now, let's see, not necessarily, we don't need to do that. So what we'll do is we can start by printing the, what do we call it? We can start by printf and then say stack implementation. And then we can actually go to, this is why I really hate the undo, stack implementation, and we can go to the next line. And then once we run the program, you can see it states stack implementation. So for the stack, there are normally some different operations. So when you're asked about the stack operations, so these are the operations that you can perform on your stack data structure, and one of them is called the push. So this is to add new data to the stack. That is the first operation. I can do, we do the second operation is what we call pop. This is to retrieve the topmost data. So this will be most likely the data that you have pushed. So whichever data that you push, it is the exact same data that you will pop. So these are the two major operations, but you can add other operations such as the display. If you want to display your stack, you can display the elements of the stack. And also you can, if you want to delete your stack, you can do a delete elements from your stack. Okay, you can also choose to empty everything, but majorly you can push and pop. These are the two major operations. Okay, these are the two major operations, the push and the pop. These are the two major, or if you want to display, you can display. And for the queue, the major operations of the queue, major of the queue, you'll see that one of the major things we have on a queue is what we call enqueue. And for enqueuing involves adding data to the queue. And then the second one is what we call dequeuing. Number two is dequeue. Retrieving the first element that we have on the queue. So when you dequeue, your involves adding data. Okay, if you add any data, we are enqueuing, but anytime you dequeue, you will always retrieve the first element. And for the first element, I mean by the element that you actually enqueued it first. The first element that you put in your queue, that is what will be dequeued. And also for the queue, you can add the display and also the delete. But the major functions that are normally required for you to know for queue is enqueue and dequeue, and for stack is push and pop. Yeah, so just that. Enqueuing, enqueue. Find references of enqueuing. Uh, and and I enqueuing enqueuing. So the spelling is really getting into me. Q ing. Yeah, I think it's the exactly what I had written before, but I need to add that hyphen. Yeah. Yeah, sorry. I think I just have an OCD when it comes to spelling. So yeah, I think everything is clear. I don't have any other spelling problem. So what we need to do is now stack implementation, and then we need to display to the user. We need to display to the user the menu. So we can have a function called display stack menu. So for this function, we can do a void display stack menu. And what this function will do is just to display the menu of the stack. So we can printf and say stack menu. Okay, and now for this menu, it will it will show you it will show you all that you need to do on these stack operations. Okay, so it will just show you maybe press 1 to enqueue, press 2 to dequeue, all those things. So let us start by doing that. I think I can add a new line, and then I can also printf and say I can print like just a cool looking that. So I want it to be like a real menu. So I'll just do that, and then I'll go to the next line, and then I'll print and then printf and say this is now will be number one. So for number one, I think I can include a tab. So for you to include the tab, you just say \t. These are some of the things that we learned. That will include a tab, and then I'll do one. And I think I can also add a pipe so that we can create like a cool menu. So number one, the operation number one will be, what will we do for operation number one? We can do a push. Okay, push. We can say push operation, and then we can do another tab. We can do another tab or two tabs, and then we can do a pipe. That is what we call a pipe. So what this does is just, let us even see how it does. So it will start drawing this menu, display stack menu. I think it's because I haven't done a function prototype of this. So let's see. Because I think in these C languages, you need to be doing the function prototypes. So let's see whether that was the problem. Um, void display stack menu. Yeah, that was actually the problem. So this is what we call, this is a function prototype. So it's good we are coding these things together so that you can actually see what is happening. So for function prototype, if you're using a separate function, when it comes to these languages like C, you need to declare a function prototype. You need to declare a function prototype so that the compiler can be able to load that function in memory beforehand. Okay, so that it can be able to load that function in memory beforehand. So push operation. You can see how the menu looks. So I need to add like 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to add I need to add 9 dashes. So I just want it to look good. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is just nothing. This is just for hii ni marembesho too. It's just for decoration purposes. So this is the first one is the push operation, and then the second one, we can actually copy paste. We don't have to leave here typing everything. The second operation will be like a pop. The third will be to display, and then the fourth one will to maybe exit the program. So number one will be that. Number two will be a pop operation, and then number three will be display operation. Number three will be a display operation, and then number four will be exit operation, exit program. It doesn't have to be an operation. So, and then after that, I can also do this. I can do that, and I can close my menu. And I have forgotten to do something really important, to always go to the next line, to always go to the next line, to always go to the next line over here, go to the next line, and also the first one, we go to the next line. So that is the stack menu, and let us see how it looks. Let's see how it looks. Awesome, awesome, awesome. So you can see this exit program is not registering well. So you can see the reason why I added this pipe. They normally call like the it's a vertical dash, vertical dash. So for the exit program, I need to check up on it and see what the problem is. Exit program, we are doing a tab, yes, and then here is number one, it should be number four. And then we are also doing a tab. We're also doing a tab, but we need to do another tab because I think it's because those words are not enough to cater for that second tab. So let's see. Awesome, yeah, and you can see now it looks good. Now we have our cool menu. Our cool menu. So you can actually try to design like an M-Pesa. You see when you dial star 544, that can be a cool program that you can think to implement like this. So this is just for displaying that menu. And the reason why I put it in its own function is so that we can always be calling this function anytime that we need. We don't have to repeat our code. So if we need to display the stack menu, we just call this function and we can actually even minimize it. And once we need to, we just call that function right over there. So now what you'll need to do, what we'll need to do is we need to ask for the user to give us a choice so that we can choose between either 1, 2, 3, 4, and know what the user has chosen. So for what the user has chosen, you need to store the user choice. Okay, you need to store the user choice. And this is what we'll actually scan from the user. And now to do that, we need to have a loop so that we can be on an infinite loop, maybe up until the user presses number 4. That is when we can exit the program. So when the user presses number 4, it's when we will be able to exit the program. And now for that we will need a while loop. So we just say a while loop. And for you to have an infinite while loop, you can do a true or false. So for a true or false, what you can do is 1 represents a true and 0 represents a false. And I don't know whether you can just out of the box write true, I don't think this will work because let's just try and build. Yeah, you can see there's a problem if you try to use the true thing. So I think that is because we need another preprocessor directive include is it bool? I don't know. I'm not sure. I'm not sure what is what stdio. I'm not sure what. So the in programming, if you're not sure about something, just Google bool in C preprocessor directive. So we'll get the answer right then. So yeah, stdbool.h. Okay. So it's stdbool.h. So that is what you need to include. So you just need to hash include stdbool.h. So I wasn't far off. It's just because I hadn't included the std. So it's bool.h. So I think that will allow us to use the true thing. So the true. Let's see. Let's build. Awesome. Yeah, you can see there's no error. So when we have included the std bool, we can be able to use the true or false keywords. So these are the inbuilt keywords, the true or false keywords. So if you want to be using that instead of using 1 for true or 0 for false, you can always include std bool. And that's why I was telling you that for these things, you can have as many what do we call it, preprocessor directive in C. You can have blah 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 conio that provides functions for console input and output operations. Yeah, you can see this is for the console input and output operations. You can see if you were to use the clear screen and gauge in your C or C++, you would need to include the gauge. And exactly this is what I exactly tried to do. So let us see whether it will work. The clear screen. So let's clear screen. Is it CL? And then we do closing. I don't know why it's not working. I don't know. I don't know, but we'll tend to see what the reason will be. But you can see from the documentation here or from the wiki here, or if you're people from the olden days, we normally were using Stack Overflow. So Stack Overflow was our chat GPT back then. So this is where you could find majorly all these errors and codes. Yeah, so this was our ChatGPT back then. So if you had any problems, just you would come to Stack Overflow and you'd get your answer. You can see these functions may include CLR and is there anyone speaking? So if you have anything, you can just type in the chat, and yeah, we'll continue from there. So I want us to quickly finish up on this because I also know you have another class. So what I was saying is that we need to have a loop, and then now for that loop, we will be getting the user choice, and then we display the menu, So inside our loop, this is where we will display our menu. So we display our menu, and also here, let me just do a tab and a tab. So while true, we will only exit this loop once 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 the, what do we call it, once the user presses maybe number 4. So if I was to run this program right now, it would always display this stack implementation for forever. So forever, okay. uh, so what I need to do is, after I I ask for the user choice, I need to scan for the user choice. So I need to scan for the user choice. So scan the user choice. So uh, scan for the user choice from the menu. And how do we scan for the user choice? You just say scanf, and then you do percent. We are using an int, so it's %d, and then you say and user choice. Scanf, %d, and user choice. And after doing that, you can use either a switch statement or an if statement. You can either use a switch statement or an else if statement to determine what the user has input. So I think we can use, which one is better? I think for such a menu, because it's not quite a lot, we can use a switch statement. So you can say switch user choice, and then you now cater for the different cases. So you say case, let's say case, the user has pressed case 1, break, and then you say case 2, break, and then case 3, break, and then case 4, and then you break, and then the default case. And then for the default, you can break or not. Okay, it's not a must you break for the default case, because the default is when the user selects something that is not on the menu. Let's say they select number 5. So after they select number 5, let's say what we need to tell them is, we need to give them feedback and say printf, uh, your choice %d. So your choice number 5 is not provided. So your choice number 5 is not provided. And then we can go to the next line. And then where does this %d come from? It comes from the user choice, and we do that. So for the, if the user does number 4, what we need to do is we can exit. We can tell the user printf, thank you for using our program. And then we can go to the next line, and then do that, and then we exit. So case 4, so we are taking care of this case 4, exiting the program. So if for us to exit, we just say exit. You can just say exit, and then you can have an exit code 0. So this is just like exiting and then returning 0. You can see here we are returning 0. It's the same way when we do like an exit 0. So let's try and see whether that compiles. And you can see it actually compiles perfectly. So what I'll do is, I will do this. I will do this and then run. So let's run the program. So you can see stack operation, stack menu. So here is it's waiting for our input. So if I input something like number if I input, let's say something like number 3, so what was the number 3? So let's say I input something like number 5. Number 5 is not provided. Your choice 5 is not provided. I input something like I input something like 8. You can see your choice 8 is not provided. So if I input something like, what do you call it, number 4 to exit the program, because we have implemented exit, thank you for using our program. And you can see process returned 00. So our operations are so far so good. So far so good. So press any key to exit. So what we now need to do is to implement our different functionalities. So for the first thing, it was to push. So we need push operation. So we need that function. And then number 2, it was pop operation. So we just say pop operation. Pop operation. And then number 3, it was displaying operation. So you just say display operation. So for these, we need to create functions for all these different things. All these different things. So we need to create the functions for push operation, pop operation, and then display operation. So display is to display our stack. So for the push operation, we can copy it, and we can minimize that. So just a minute. So I can minimize that display stack menu, and then I can say void void what, void paste, void push operation, and then we do that. And then for the other function, it is void pop operation, and then the other last one was void display operation. And remember, we need to write function prototypes for these functions. So we have to write the function prototypes, because if we tried to build our applications, you can see push operation is not defined. Also, the next one, pop operation, and also there's no declaration of the display operation, even though everything is okay, but you need to do the function prototype. So we just say void push operation. It's even doing that for me. Void pop operation, then void display operation. Simple. And now once we do our build, you can see our program is building quite well down here. It's building quite well. So yeah, that is more of it. So what you need to do is just to now display this. And out of all these complex data structures that you will ever find, that's why when we were doing an introduction to C, I told you one of the most important data structures is what we call the array. Because at the back end of the data structures, all these major data structures, you will find it's just an array. And it's exactly what we are going to use. So we are going to use an array to implement our stack. Also for the key, we are going to use an array. So that just shows you the importance of an array. That's why I was really telling you to really get or understand arrays. So for this case, we will need to define. So we can do another define. So we can define a static value, max size. So array. So let max size. Okay, we can just say max size and it will be something like 10 or 5. Let's start with a simple. So this will be the maximum size of our array, or the number of items our, let's even say something like even 10. Okay, something like 10. So max size will be what we initialize our array with. So it's not a must you define like this. You can even say something like int int max size. Okay, you can say is equals to 10 or 5. It's just the same thing, but in this case, we are using a directive, okay, a defined directive. So yeah, it's majorly, you can also do like this if you wanted to, but in this case, let's use another directive. So that will define the max size, and now that is what we are going to use our array with. So our array will be our stack. So we just say int stack. So our stack will have the max size. So our stack, so you can see it's just defined as an array. So don't let this stack fool you. This is just basically an array. It's just that we are naming it stack. And in this case, we are naming it like that because we want to implement a stack from scratch, okay? From scratch, because now from scratch, all these data structures, they are defined like this. And then for a stack, keep track we need to keep track of the top element. So for that, we'll use this. So we say int top, we can say top element is top element. So it's like the index, top element index. So we can call it an index. Top element index. You know what an index is when it comes to an array. So for the top element index, we'll start at -1, so that we can uh, go to, if we want the index 2, if we want the item at position 2, -1 will be index 1. But you'll see how we'll actually determine that. So when we start doing now our functions, so let's start doing our push function. Okay, so for the push function, where is the push operation? This push operation, we will be pushing in a number. So int number, int number, okay, int num. And then after doing that, so what we need to do is we need to ensure that the top, okay, you see this top that we have here. So if that top is equals to max size, so if that top is equals to max size -1, the max size is what we defined up there, so the maximum size, and in our case we said the maximum size is 10. Okay, we said the maximum size is 10. So if the top, so it will keep track of the items also that are on our stack. So if that is equals to 10, or max size is 9, so that's the reason why we are starting top at -1. Okay, so that because indexing starts at 0, that the same way we were doing the less than and the less than equals to, less than and less than equals to. So you are using the less than when you don't want to reach to that number, and that is the same case we are using top, because top is starting from we are determining it from -1. So if the max size -1, because top will start at 0, so you'll see us incrementing top like something like top plus plus, because we need top to start at 0. So I will comment that when we get to that, but that is the rationale. So this is to ensure that the stack is not overflown. Okay, because if it's overflown, you'll get into problems. So if top is equals to max size minus 1, you can say that the stack is already full. So you printf to the user and tell them your stack is already full, and then you do that, and then we can go to the next line. So this is just to determine whether the stack is actually full. And then what you can do is we can return. So we don't want to perform any push operation when the stack is full. So that is what will ensure that the stack is already full. And actually, this is what we call a stack overflow exception. Stack overflow. I think Stack Overflow, the website that we were just from right now, maybe they got the inspiration of the name from a stack. Maybe they were receiving so many Stack Overflow errors, so many Stack Overflow errors. So that's why maybe they decided to call themselves Stack Overflow. Actually, we can do why why did Stack Overflow call themselves Stack Overflow? I don't know. The name, blah blah blah. The name of for the was chosen by voting in April by readers for Code of Coding Horror, Altitude Programming. Okay, so yeah, what is Stack Overflow? Stack Overflow is a type of buffer overflow that occurs when a computer program tries to use more memory space in the call stack, okay, to allocated to that stack. So you can see this actually gives you another use of a stack. It's really used in computer memory too, and also managing things in memory. So when computer doesn't find any memory, like what we have done here, let's say it did not find this, like it tried to access an element that wasn't in the stack, or the stack was already full, you will get a stack overflow. So a stack is also used in computer memory to manage quite a number of spaces. So yeah, so you can see that. So these are things you can just research anytime. And then after the user selects the push operation, you can just tell them to enter enter the element that you want to push to the stack. And we can go to the next line and do that. And this element is the number that was here. So we can say, we can actually call it number to push. Okay, and then we scan it here. So we'll let the user scan and say scanf, and then we say percent %d, it's an integer, and then we say number to push. And then that will scan the number, and after we scan the number, we now need to add that number to our stack. So we just say, we now increment our top, we increment our index. So this keeps track. I think I had actually track of the index. Okay, track of the index too. Okay, so we increase the index of the of the increase the index to store our element. Simple as that. So, and then after doing that, you just say our stack, the array index top. So our stack index 0 is equals to number to push. Simple as that. So that has pushed our number to the first element of the stack. So this will be something like, because we are incrementing top, the index, and it's starting at -1. So if we increment it plus plus, it will start at 0. That is the reason why we really need to start at -1, so that if we increment, we start at what do we call it? We start at 0. And the reason why someone can ask, why don't we start at 0? Because when we increment here, we will go to 1, and that will already be index 1. And we all know that in computing, counting starts at 0. So that is the reason why we are starting with -1. So that is basically it. Okay, that is basically it. Nothing much. So for our pop operation, what you need to do is to retrieve. So the pop operation, this retrieves the topmost element in our stack or array. Actually, it's an array because you saw that. That's why I told you it's really important to understand how arrays work, because they form the basis foundation. So int number to pop. So that will be the number that we will pop. And we say that if top is -1, okay? So if the top is equals to -1, we are going back to -1. So when we go back to -1, this means that the stack is empty. It means that we have popped all elements. Because when we are popping, we will be doing a top minus minus. So we say if top is -1, we tell the user, we printf to the user and tell them that oops, sorry, the stack is empty. Okay, the stack is empty, and we can go to the next line and do that and do that. So we tell them that the stack is empty, and then we return. So that when we say return, we break out of the function. We just break out of the function. We don't continue executing in the function. So after doing that, so it is very simple. We just say the number to the number to pop is equals to stack, and then the top. Okay, the top, because the top is keeping track of our index, we are using the top. And then here is now what we do, the reverse. We say top minus minus, as simple as that. So this is just the pop operation. So the pop operation will give us the top element, and we need to minus minus. And now when we are minus minusing, when we are decrementing, we'll get to a point where we will get to -1. And when you get to -1, the stack is literally empty. And then for the display, so for the display is just the same thing. So for the display, we need to, for us to display the stack, we need it to have at least one element. In short, it should not be empty. Okay, so for that we need to test again and ensure that it's not empty. So for that, it's just the same logic that we have done like up here. You just test that it's not empty. So you can copy that and paste it. So this is to ensure that it is our stack, first of all, is not empty. And then now we display our elements. And for displaying our elements, we can say printf and say stack elements are, and then we can go to the next line and do that, and we can display using the for loop. So we can say for int I. So for loop, we'll always use int I. So you can say for I is equals to 0, and then I is less than the, what do we call it, the top. Okay, for, okay, this is now like displaying. If you want to display it from the first index to the last, we can do that, but in our case, let us display it, in order of how the stack looks like. So if we have number 7 at the top of the stack, we display it like that. So we start from the topmost element, and then we say I is greater than or equals to 0. So it will go from that topmost element to 0, and then we say I minus minus. And then we can display. So this will just display our stack on how it looks. You can choose to display it from the beginning, like how I was initially doing. So you just say printf, and then you say, you can say stack index. So we index %d. So that is the index of the stack. What does that index contain? You say it contains. So you can say has number, contains, or you can say contains, contains percent d. So we will say stack index 0 contains number 7, because we'll actually start doing, then stack index I. Simple as that. So what this means is that we will display, if we have input number 7 in our stack at index 0, it will say stack index 0. So stack index, so contains, so we can do that, contains that %d, and then we can go to the next line. So we say stack index 1 contains that, stack index 2, and that is basically our program. That is basically our program. So let us build and run, and let us maximize. And what you need to do is we can also, what we need to do is, we can do a push operation. So a push, enter the element that you want to push to the stack. So remember, our stack is having 10 items, so I can choose a number like 657. What I need to do again is I need to push, so I can push the second number, enter the element 788. Then I can do again a push. So this number I will, so now take a keen at this number I will push. So I will push number 4. So I'll push number 4. So if I push number 4, I think we should be telling the user if you have pushed. So we tell the user number 4 has been pushed, but that is for you to add. So now I want us to display our stack. So let's see how it will display. Uh, okay, stack index 2 contains 0 0. Yeah, it hasn't been recording. So it hasn't been recording. So I think we have a bug on our, where is the display operation? Contains stack index I. So where I think we have a bug at the, what do you call it? Stack index top. So we have a bug at uh, at at our push operation. So let us hunt for that bug. So our push operation does the, we push, or maybe it's the display. So let's see stack index I. Oh, I know the reason why. I know the reason why, guys. So for us to be able to see all those numbers, we need to push up until we get to number 10. Up until we get to index 10. So I would need to push, because it is getting, because we started from the top. Okay? So Uh, yeah, and for the top, we have we start defining. Let's just deal with like very few numbers. Let's deal with like three numbers, and then we see maybe what the problem is. So let us see. If it doesn't work, we need to debug. So let's do that, and then let's do a push operation. Enter the element you want to push to the stack. Or another problem would be having that. I know another problem where it can come from. So 54. You see how it's asking me to enter twice. 554. And then we push again. 4. And then let us try and display. So we definitely have stack index 2 contains 0. So we have let's try and do a pop operation so that we see whether our data is there. Huh. Mhm. So it's not also doing a pop. So let's just see where the problem is. Push. So the number to push. Stack index top is equals to the number to push. I think we are doing our push operation perfectly. Int number to pop is equals to the stack at index top. Okay, so I think I see the something here. So the top is defined is a global variable. So stack elements are I. So let us just debug together. So this is basically what happens in the general world because we were live coding together. Yeah, this is not like something I have even tested. So for now, I think we just need to debug. Uh, or we can do or we can ask Claude. Actually, let's just ask Claude where the bug is. So actually, for those who have never used like Claude is like the best when it comes to programming. I can tell it the problem, and tell it the problem is that the when I display when I display the stack when I display the stack, what was a real problem? So let me just change this to 5. When I oh, okay, so let us do control all, then control. When I display the stack, the elements of the stack display as 0 all through. Where is the bug? Okay. Where is the bug? In my code below. So I just paste the code and Cloud will just give me the bug right away because I can see it right now and we don't have time. Oh, yeah, exactly. So I think it's a very ridiculous thing, and it's because I knew that it was a problem with the push operation. So the push operation is because I forgot to put one of the most important things that I was always reminding you in class. This and, where is that and? Okay, it's because I forgot to put the and. So scanf number to push. You have to put an and I always warned you about this in class. Okay, I always warned you about putting this and the reason why is if you don't put that and, it will always substitute this number to zero, and that is the reason why it was displaying us zero, and that was actually correct. So basically that was the error. So unfortunately, so you can see how these AIs are coming in really handy these days. So that was basically the problem. So push element that you want to push. So I want to push 453, and then the next element I want to push is I want to perform a push operation. I want to push number 45, and then I will push all the 5 items. So 544. So this is okay. Also, you can see actually my choice 544 is not provided. So I want to push. I want to push. So I will push that you want to push 675. So how many numbers have I pushed? One, two, three, three. So I need to push two more. So I need to push two more. So I need to push two more. So push 7. I will push number 7, and then that is the first one, and then I will push number 4, so that we when we pop we see number 4. So I will push number 4. So I think if I try to push, have we catered for that logic? If I try to push another number, it should tell me my stack is already full. You can see that it's not provided. So I push. Yeah, exactly. Your stack is already full. Stack overflow. I think I should have not pushed. So what I need to do is now display operation. You can see exactly what we have. So imagine, just imagine our error was this, just this and was our error. So it's just crazy how we could have spent so much time, because I was thinking maybe top is not a global variable, but my eyes couldn't see that. I forgot, and most of us were also forgetting this and. So because I also knew that it's something that is quite prevalent. So yeah, you can see the stack elements are 4, 7, 675, and I did 4 as the last, and you can see it's the first here. So if I pop, let us perform a pop operation. Let us perform a pop operation. So a pop operation will should get rid of number 4. So pop should get rid of number 4. I have popped. So let us display the operation and see whether number 4 is there. You can see number 4 is actually not there, and we have popped our stack, and our number 4 has gone. So the next, we can also do another pop. So you see we get rid of number 7. We do number 2 another pop, number 2 another pop, and then we like display. You can see we have popped number 7, and we have 675, 45, blah blah blah. And let us actually just pop them all. Let's pop them all. Let's do another pop, and let's view. I think I have popped twice, so I think we should be having just like one. Yeah, you see we have just one element, and when I pop it, let us pop it. Let us pop it number 2, pop operation, and then we display operation. Oops, the stack is empty. So you can see our stack is now empty. Simple and clear. So that is all for the stack operation. So you can see that is the stack. So the reason why I wanted to start with the stack is because the stack is the more complex of the two, between the queue and the stack. So once you understand how this stack operates, once you understand its code, you'll be able to just do the queue very well. So this is just the stack operation. I will share this code with you. I will send to the class rep, and also the recording. I have made the recording. It should be available. I will just share with you the recording, and you can see for the exit program. So let's do the exit. So let's exit. Thank you for using our program, and it exists. It exists. So this is quite nice, and you have seen we have been able to write our program, and we have seen how we can actually solve some very weird bugs. So if you maybe just get weird bugs in your code that you don't understand, you can always be using something like Claude. Like Claude, in my opinion, is literally the best. It beats even ChatGPT, the latest versions, whatever, when it comes to programming. So when it comes to programming, I would really advise you to try out Claude. It has been like the best. I even literally pay for the professional plan. So if I pay for something, just know it's really worth it. So I would advise you all to, when it comes to coding, just try out Claude and like something like ChatGPT or all these others. I have used everything, and trust me, when it comes to programming, yes, for general things, ChatGPT is good, but when it comes to programming, I think Cloud is undefeated. So yeah, you can see it's even telling me to consider clearing the screens between operations for better user experience. So it's even giving me the code to clear the screen for a better user experience, because it has seen that my code does not have a better user experience, because I'm always scrolling. But when I implement what it has told me, you'll see that it will be very, very easy. So if I clear the screen right over there, and then I think I can where else can I clear the screen? Maybe I can be clearing the screen every time I want to start. So let us see. So yeah, you can see Cloud is really good. So uh, look at its recommendation. So its recommendation, I'm sure when I select one, it will be enter the element you want to push, 564. So you can see it's actually working, and it's clearing everything. When I say display, you can see it displays the elements as 564, and I don't need to now keep on struggling to do what, to scroll again. So yeah, I think I will share this program with you, and yeah, that's basically it. For programming, I always advocate for Claude. You can see it as even just out of the, I didn't even ask for it to, but it just knew that my program doesn't have a good user experience, so it even gave me that code to be clearing the screen. So the main bug is definitely missing the and in the scanf. Yeah, so that was just it. That was just it. And I think it's the next, it's your next lesson. Maybe if anyone has a question. The session has been recording. Oh yeah, sorry about that. So yeah, this session is over. You can now proceed to the next session. So yeah, maybe if anyone has a question, I can stop recording.